Hey everyone, a very happy new year to all of you. And on the words of New Year evening, I have decided to record this video on Docker networking, and we'll start with the Breeze network driver. It is one of the default network driver which comes pre-installed when you install Docker on your machine. So we'll see how Breeze network mode allows communication between your Docker container. We'll also see the difference between the default Breeze mode and the user-defined Breeze mode and see when to use which one. So without any further ado, let's get started. So before we jump straight into the demo, I just wanted to quickly show you how the Docker Breeze network works from an architectural point of view. So the H0 interface that you see here right at the bottom is actually the interface for your host. This might be named differently depending on your operating system. So for Linux, it's usually H0. For Mac, it has EN0. So depending on your host, it could be different. But remember that that is a primary interface for your host. And that is how it connects to the external world or to the internet. Then Docker creates an internal Breeze network or an internal network, which is often named as Docker 0. So whenever you run containers without specifying any network type, it will run your containers inside the default Breeze network, which is Docker 0. So each container gets their own virtual interface and they get their IP as well. So for an example that is shown here, the web container gets an IP of 172.170.0.2 and it is connected with the Docker 0 Breeze network using the virtual interface. And that is indeed connected with the main parent interface of H0, right? And that is how the containers can communicate with the external world. So you can also create your own Breeze network, for instance MyBreeze, which is shown here in the example. So you can run containers by specifying a specific Breeze network. So by default it runs in the default Breeze network, which is named as Docker 0. But if you specify a specific one, let's say MyBreeze, then the container will use the configuration for the MyBreeze network and then assign the IP to its container. Again, the MyBreeze container would also be connected with the primary interface of H0 and can reach the external world. But remember that since MyBreeze and Docker 0 are a separate Breeze network, so containers in one of the network will not be able to talk with the other network. So let's say the database container shown here will not be able to make calls or communicate with the web container, which is in the Docker 0 network, but the other containers which are running inside the Docker 0 or the MyBreeze network will be able to communicate among each other. So that's a quick overview. So let us see all of this in action. So right now I'm in the Docker desktop console. So I have installed Docker on my machine using the Docker desktop for Mac, which makes the installation process really easy. But you can also install it for other operating systems such as Windows and Linux. And for Linux, you can also install directly from the source without using Docker desktop. So once you have the engine up and running, let us go to the terminal and see all things in action. So let me clear that for you and zoom in a bit to make it look more clear. And the first thing that we are going to do is check if the Docker is running fine or not. So let us start by running the docker ps command. And you can see that we don't have any containers running at the moment. That's why the list is empty. Next up, we are going to do docker network ls, and that will list all the current networks on my Docker host. And you can see that we have the Breeze network already up there. Remember that we did not create this network automatically. It was already there before we created it. Next, we will try to run two different containers to see how the Breeze network performs and how the containers by default are attached to the default Breeze network. So we'll run the Alpine 1 container, and this is using the Alpine image. Remember that we are running it in a detached mode, and we have also enabled the interactive terminal session. So whenever we attach it back, we get direct access to its cell. And we are now checking if the container is up and running. We can check that using the docker ps command, and here you can see that the Alpine 1 container is running. Next up, we will run the another container Alpine 2 using the same image. And now if I do docker ps again, we can see that both the containers are up and running. So let us go ahead and inspect the default Breeze network. So if I do docker network inspect and then the name of the network, which is Breeze, you can see the different name, ID, the driver, which is default in this case since it was created by default. You can also see the subnet for the network driver. So this is going to be the range of the IP that the containers will get. And you can see that most importantly, there are two containers in the containers config section. So both the containers that we ran earlier, Alpine 1 and Alpine 2, are using the default network driver. You can also see the IP of the individual containers. So the first containers have the IP of 172.17.0.2, while the other one have 172.17.0.3. Also notice that we have the breeze name as Docker 0. So now in order to check if the containers can communicate to the external network such as the internet or among themselves, let us first attach the cell of Alpine 1 container. So I'll do docker attach Alpine 1, and this will attach the Alpine 1 session to my own terminal, and I'll do IP addrso, and this will list me all the network interface for that Docker container. And you can see that we have 4 different interfaces over here, and if you see the ETH0 interface, you can also check for the IP which exactly matches from what we saw when we did docker inspect and network, right? So that is the IP for the container. So let us go ahead and now try to ping google.com. So I'll run the command ping-c to google.com, and that will ping google.com for 2 times. And you can see that we are able to connect to google.com as both the packets that were transmitted are received. Now let us also check for one more external network. So let us try it with twitter.com, right? And you can also see that we got the response back. So you can see that the containers, when they are running in the default breeze mode, they are able to communicate with the external network and the internet. Now let us try to see if they can communicate among themselves. Remember, both the containers Alpine 1 and Alpine 2 are inside the same default breeze network. So let us first try to find the IP of the containers and try to ping Alpine 2 container from Alpine 1. And for that, I will list the containers using docker ps, and I will inspect the Alpine 2 container. So let us go ahead and do that, docker inspect, and I will copy the ID for the Alpine 2 container over there, and under the network section of that container you will be able to find the IP address for that container. And inside the terminal of Alpine 1, I'll try to ping using the IP of Alpine 2, and you can see that we are able to ping container 2, which was Alpine 2. So that means that our containers can communicate among themselves as well, other than the external network. Now let us also check if they can communicate using their names. So if I now copy the name of the container, which is Alpine 2, and try to run the ping command, you can see that we are not able to connect, and it returns a bad address. And remember this point, as this will be crucial when we try to understand the user-defined network mode. So remember that containers in default network mode can communicate with each other using the IP address, but not using the container's name. So let's go ahead and remove both the containers. I'll use the -f flags, and that will stop and remove the container if they are running. So that was about the default network mode. So remember that anytime when you run a container without specifying a network, then it always runs on the default network mode, and the containers on default network mode are able to communicate with the external world using the internet, as well as they can communicate with other containers running on the default network mode by their IP addresses, but not using their DNS name. So now I quickly want to show you all how port mapping works in Docker. So I'm trying to run an nginx container over here. So let us do docker run -p and do a port mapping. So the first port specifies the host port, that is port 3000, and the second port is the port for the container, which is 80, since nginx runs on port 80 by default, and we're using the nginx latest image. So what this does is that it binds the port 3000 on our host machine on my laptop to the port 80 on the container. So let me also quickly run the second container, and this time I will map port 3005 on host to port 80. And if I do docker ps, you can see that both the containers are now running, and the mapping is also correctly displayed. So first container is mapped on port 3000, while the other one is mapped on port 3005 on host. And this clearly shows that we could potentially run multiple containers on the same port, provided that they are binded to different host ports. Let me quickly pull up my browser to see the nginx containers. So I'm here in my browser, and if I do localhost port 3000, I should be able to get the nginx container. So yep, I can see the nginx container is up and running. And if I also quickly switch that to port 3005, I can see the nginx container is accessible here. So that was about the port mapping that I quickly wanted to show you all. So now let us go ahead and create a custom breeze driver. This time we will use the docker network create command and specify a driver flag with breeze mode, and we'll give it a name of alpine8, and you can see that the docker network is created. And now if I do docker network ls, I can see all the list of the network. So you can also get the alpine8 network that we just created. And let us now try to inspect the alpine8 network. And if I do docker network inspect, you can see that the alpine8 network is using the driver as the brace, and you can also get this subnet and gateway for the containers. So the IPs of the containers will belong to this range. So now let us run some containers in this network. First, I will run the alpine1 container using the alpine image. We give the network flag and provide the name of the network as alpine8, and then we run the shell command. So now if I do docker ps, you can see that the alpine1 container is up and running. So let us also quickly spin up some more containers. So let us do docker run, and this time we are running the alpine2 container using the same network as alpine8. Now if I do docker ps, you can see both the alpine1 and alpine2 containers are running. So let us also go ahead and create a third container, and again I will use the docker run command to do so. And this time I don't attach it to the alpine8 network. Remember that alpine1 and alpine2 were in the alpine8 network, but alpine3 will be using the default breeze network. Now if I run the alpine4, and this time the alpine4 will also run in the alpine8 network. So remember that alpine1, 2 and 4 are running on the alpine8 network, while the alpine3 is running in the default breeze network. And now I would like to also attach my container 4 with the breeze network as well. So alpine 4 will now have access to both the default breeze network as well as the alpine8 network. I can do that using the docker network connect command. And now if I do docker inspect, and then I can do breeze first. So let us try to inspect the breeze command. So I can do docker inspect and breeze, and this will give me the list of containers that is using the default breeze network. And you can see that alpine3 and later when we did container docker network attach and alpine4 are using the default breeze network. And now if I do docker network ls, I can see all the network here again. And if I do docker inspect alpine8, you can see that alpine1, 2 and 4 are running in the alpine8 network as I mentioned earlier. Now let us do docker ps to list all the running containers, and I would like to attach the alpine1 cell. So now I'm inside the alpine1 cell, and let us try to see and try to ping the alpine2, alpine3 and the other containers. So you can see that whenever I try to ping the alpine2 container using its DNS name or the name of the container, you can see that I am able to connect with that container, right? And that right there is the major difference between the default breeze network mode versus the custom breeze network modes. Because if you remember earlier, in the default breeze network mode, we were not able to connect with other containers using the container name, right? Although they were in the same network, we had to connect using their IP addresses. But in the custom breeze network mode, we can connect to the containers if they are in the same network using the container name, because internally what Docker does is that it adds the name of the container as the DNS host name in its etc/resolve.conf file, which is the file that the container uses to identify and resolve the DNS names locally. So that is how the Docker containers in the custom breeze can communicate with each other, because it creates an internal name server and configures that etc/resolve.conf file to identify containers just using the DNS name or the name of the container. So that is about the Docker custom breeze network. So now let's try to ping the alpine3 container, and you can see that it returns a bad address, because remember alpine3 is not in the alpine8 network that was created, it is just in the default breeze network. And that shows how custom networks can allow us to isolate containers. So this is also useful for whenever, let's say, you're working with multiple applications or stacks, so you want to isolate the containers, then the custom breeze network is one of the good way to do that. So we can also check if we can ping Alpine 4, and we should be able to do that because they are in the same network. And there you go, we can ping the Alpine 4 network. Now let us also try to ping the Alpine 4 network by the IP address, which would normally work, because if we are able to ping by DNS name, indeed it would be using the IP address. Let us quickly confirm that by copying and pasting the IP address, and you can see that we did get the response back here. Now I'm able to ping the container 4 by the IP address as well. So now let us try to attach the cell of Alpine 4, and from Alpine 4 let us go ahead and try to ping Alpine 1, and you can see that I am able to ping Alpine 1, because remember Alpine 1 is in the Alpine net network, and Alpine 4 is also in the same network, so they should be able to ping with each other. But with the Alpine 3 network, although both Alpine 4 and 3 are in the default bridge network, remember when we attached Alpine 4 to bridge network, it should be able to communicate to Alpine 3. But remember, in the default bridge network, we cannot use the DNS name. That's why we were not able to connect with Alpine 3 using the name. But if we try to connect using the IP address, so let me quickly grab the IP address for Alpine 3. It is now able to connect with the Alpine 3. So that is about the custom bridge network and how it works under the hood. If you want to disconnect any containers with any of the network driver, you can use the docker network disconnect command. Here I am disconnecting the Alpine 4 container from the bridge network now, and if I now inspect the Alpine 4 container, you can see that it is just attached to the Alpine net, as it was successfully disconnected from the bridge network. Let me quickly remove all the containers using the docker container rm. Remember, you could just use docker rm, but in the newer version it is recommended to use the docker container as the command name, but both works. And now I will also remove the Alpine net network. So you can also assign the subnet range and the gateway for your containers whenever you create a network. So using the -- subnet flag and the -- gateway, that way you would be able to specify the CIDR range for the subnet as well as the gateway. So if I do docker network ls, you can see that my custom base is also created now. So that is all I wanted to talk about the docker network modes, especially the default bridge mode versus the custom bridge mode, and I am hopeful that you are all clear about that now. If you like this video and want to learn more about cloud and DevOps and how things work under the hood, please subscribe to my YouTube channel, as I plan to post regular videos to make DevOps simple for you all. Thank you, and I'll see you again.